Hello, everyone. How are you doing? I trust you're all doing great. James from JTS Maths Tutoring here. Today, we are going to be looking at this question here. Under what conditions on A and B will the following linear system have no solutions, one solution, or infinitely many solutions? All right, let's get going. Step number one, rewrite the given system as an augmented matrix, which is what I have right here. Step number two, convert the augmented matrix into either raw echelon form or reduced raw echelon form, which is what I have right here. Step number three is now to test the following possible solutions using the last row. Okay, so let's get going. Right, so for this system to have no solution, the last row is supposed to look like this. Consistent, B is not supposed to be equal to 2A. All right, what about for it to have exactly one solution? The last row is supposed to look like this, of which when you're coming to this, you're actually having a 0 here, so which means 0 is equal to 0, but here we are having a such contradictory. So we conclude that it is actually impossible for us to have a unique solution here regardless of the values of A and B. All right, let's move on to infinitely many solutions. The last row is supposed to be full of zeros, so it's supposed to look like this. This means that for this system to have infinitely many solutions, B is equal to 2A. All right, I've got another alternative solution right here, right at the bottom here. Okay, so check it out. We are dealing with conditions for solutions here, okay? So for us to have no solution, A, which is not supposed to be equal to C1, C2, okay? I'm not gonna bore you with the rest here, but all I just want you to know is that your A1, your A2, your B1 and your B2, these are the coefficients of your X and the Y variables respectively, whereas your C1 and your C2, these are constants, the results, okay? So your first step here, you now need to determine the values of the coefficient from the given system. So we know that A1 is going to be equal to 2, A2 is going to be equal to 4, B1 is going to be -3, B2 is going to be -6, C1 is A, and C2 is going to be B. Okay, let's do the magic here. We can see just like what we saw earlier on, that for this system to A, and let's do this, you can see here, half is not equal to half, which is not true. So it's actually a contradictory statement. Therefore, this system is not going to have A and B. Right, what about infinitely many solutions? You can see, just like what we saw earlier on, B is equal to 2A. That's for the above system to have infinitely many solutions, B is equal to 2A. That's it, we are done. Allow me to do what my mama taught me. A good visitor knows when to leave, or she would say a good dancer knows when to leave the dance floor. See you when you see me. Till we meet again, I want you to be rest assured that at JTS, we are committed to keeping you mathematically informed. Adios, amigos and amigas. See you soon.